This is the 6-5 alpha lesson on fraction decomposition. And on the Google slides, this actually worked out with what's in our book, day 1 and day 2. A lot of times it doesn't work. We only do one of those PowerPoints, but this coincides with how we're going to do this. So you want to anti-differentiate this example. In fact, let's do this. Let's back up. Let me do this first. Let me do the half of the PDF first. So here's the question from the end. And this is logistic growth. This is what we'll do next week. But just read it so you understand what's being asked. The spread of a disease can be modeled by this equation, where F of T is the number of people infected after T days. How many people are infected when the disease is spreading the fastest? Okay? So you can't possibly answer this until after we deal with what we're going to do on next Thursday. But this is like the problem you did with Mrs. Bratz about the fish in the lake, where the fish are growing exponentially until the lake's too crowded, right? And then the growth slows down. So that's what logistic growth is about. So we're just going to go here. In example 2 says this. Oh, good old-fashioned long division of polynomials. We're going to do this if the degree, that's why I backed up from the PowerPoint, if the degree of the numerator is bigger than the denominator. And we want to anti-differentiate this. We anti-differentiate it we start by doing long division. So we write out the dividend underneath the division sign, and we give zeros to all the terms that are missing because it goes from x to the 4th to the constant. So you have to account for those places. 0x to the 3rd, 0x squared, 0x. Our divisor is the denominator. So what do? We divide the first term in the divisor into the first term in the dividend. So you'd have 3x to the 4th divided by x squared, which gives you 3x squared. So I put the 3x squared above the x squared in the dividend, distribute this, and you subtract. I didn't show you the subtraction. I mean, it's kind of, I hope that makes sense to you. And what happened? You divided a 4th term polynomial by a 2nd term. So you got a 2nd term, but you had a remainder. So where would you be? Well, now I'm going to differentiate this. My quotient plus my remainder over my divisor. Well, this power rule in reverse, this power rule in reverse, this we got a problem. So this, we're going to use fraction decomposition. Why? Because the denominator is mu equals x squared take away 1, and you would need d mu of 2x, and you can't introduce that. So you have to break this down, okay? So we're going to deal with fraction decomposition now on the PowerPoint, but it's only for the back half of the problem, because the degree of the numerator was bigger than the degree of the denominator. So how do we do fraction decomposition? We're here. Now, ready? Now you're looking and saying the degree of the numerator is lower than the denominator, which is where we were in that problem after we did the long division. Okay? So you got to look at the question before you start doing it. If the numerator has a higher degree, you do long division. Here, the denominator is larger. Yeah, we're going to factor this and see if that term reduces with that, but it won't. So how do we do this? This gets factored with a lattice. What happens? We need two terms that multiply to two linear factors that multiply to x squared plus a negative 2x plus a negative 3. So we build a lattice. What multiplies to negative 3? 1 times a negative 3. Or negative 1 times a positive 3. But we need the middle terms that up to negative 2x. So that's what we would get. So now what? Can we write this into the sum, right? Like when you would bow tie this. Can we write this into a sum of two fractions with those distinct denominators? And when we add these fractions and we bow tie it, we have to get to here. Okay? So now what? Well, we clear the fractions. We multiply both sides of the equal sign by this denominator. And what would happen? On the left side, you would just get the numerator. On the right side, when you multiply this product times this term, the x take away 3's would reduce. So you would get a times x plus 1. When you multiply this times the second fraction, the x plus 1's would reduce, and you would get b times x take away 3. So now what? Well, we're not going to do it this way. I'm going to fast forward through this. There's a much more user-friendly way to do this. Sorry. So we're here. Ready? Same thing. That's where we left off. So if you make this term right here 0 by making x negative 1. If x is negative 1, this whole thing is 0. And this would be a negative 1, and that would be a negative 1. So this would be 5 times a negative 1 is a negative 5, plus a negative 3 is a negative 8. This is all 0. This is negative 1 plus a negative 3. That'd be negative 4b. Divide both sides by negative 4. B is 2. This b up here would be a 2. Now, make x 3. We're going to make this term go away. Go away because it's going to be 0. So we put 3 in for x. We get 15. Take away 3 is 12. 3 plus 1 is 4. 4a. And this is going to be b times 0. You're making these a's and b's be 0 one at a time. So that's how you're getting these x values. Make these linear factors 0 one at a time. So you get 4a equals 12. A is 3, which means what? We go back to this question and we can take this and paste it here. And where there was an a, we write what a equals, which is a 3. And where there's a b, we write what b equals, which is a 2. Meaning this question right here is the same as the original problem. Fraction decomposition. Now, ready? We can anti-differentiate this. So what would you get? You would get, ready? This is mu is x plus a negative 3. But it's mu to the first. I'm sorry, mu to the negative 1. So when you add 1 to that, you would get mu to the 0 divided by 0. You can't do that. So you get ln mu times the numerator, 3 ln mu, plus 2 times ln second mu for the denominator, plus the constant. Okay? Now, see, this answer here corresponds to that question. Unless you understand how to do this method, there's no way you're going to match up this answer with that question. Okay? But the method's not difficult. It's just algebra. So this will be on the test. So back here, we would use fraction decomposition for this. And we would break this down into x plus a negative 1 times x plus 1. We would have a over the x take away 1. Doesn't matter what order you do it in. B over x plus 1. And we would do the exact method you just saw on the PowerPoint. Okay? I didn't go into detail on here because this is in the book. Like, I didn't just retype everything that's in the book. If you need to see that, we're here. Here's where they did this, ready? In the textbook, here's the long division, which we showed you, and you end up with this thing. So this, the third term that's being added here, that gets broken down into fraction decomposition, becomes A over one factor and B over the other. It, again, doesn't matter what order you write the linear factors. Then what did they do? Made x 1 after they bow tied it. X being 1 makes B 0. X being negative 1 makes A 0. And you got these values. And got this. The left two terms get anti-differentiated by the power rule in reverse. And the rest of it gives you ln's because the mu is to the negative 1, right? And I wouldn't worry about this last line. If you leave it as this line, it's 100% correct. Okay? So I'll leave the textbook up here. Now you're gonna kind of, I don't know what you'd rather see. Because if I go here, you can see the long division. So on the PDF, so I'll leave it up to you, whatever you want to see. Here's the PDF, that's the long division, how we got here. And the textbook is showing you what was on the PowerPoint, how they got from there to the bottom. All right? So they got from this term, which was the remainder over the divisor, down to here. Okay? So I'll just move it. I'll start with this. Here's the long division for you to see that. And then I'll move it back to the textbook. So you're going to go and use this to do, I'm going to pause the video. And you're going to use this to do problem number 7, please.